Hey guys, welcome to Learning from Gliders, hosted by the Learning Farm. My name is Daewoo, and we're going to learn a few things about flying today in a three-part video series. Through the lessons, you'll be learning some basic terms and principles about flying, some of which you may have heard before, but I'll be doing my best to simplify ideas about why our gliders behave the way that they do. I'll also be including some challenge questions for those of you who want to think and research more about it on your own. Now, for these lessons, you're going to need a few things. One is a balsa wood glider kit. Well, this one's assembled, but the kit that is included with your learning package. A tape measure ruler. It also wouldn't hurt if you had a normal 12-inch ruler. And a safe space to fly, preferably indoors. So let's begin. First, let me quickly introduce myself. Once again, my name is Daewoo, and I'm an aerospace engineer at Aurora Flight Sciences, a company that specializes in autonomous airplanes under Boeing. I've worked on numerous projects, but the current one that I'm working on is pictured below. It's called PAV, P-A-V, which stands for Passenger Air Vehicle, and it's designed to move people from one place to another, kind of like an air taxi. Another fact about me is that I currently live with my wife, Anna, in Cambridge, Massachusetts. However, soon we'll be moving to Atlanta, so I can begin my PhD at Georgia Tech. So our first lesson is going to be about the parts of an airplane. Now, if you haven't already, go ahead and carefully open your glider kit. And I mean carefully. The balsa wood is actually easier to break than you might think, so be careful. And you'll find the assembly is quite simple, and there are directions on the package itself. And once you're finished, you're going to have something like this. And if you notice, my pilot is actually not there because he broke off. And I can't stress this enough. The balsa wood is a bit more fragile than you think. Now, before we begin learning, you have to try flying it. Now, make sure to be careful of your surroundings. Never throw the glider in the direction of someone else, and come back once you feel like you're ready to learn more about gliders. So feel free to pause the video now. Are you done flying? Let's pick up where we left off. Now, the first thing after we fly a glider is we're going to learn to name each of its parts. I'll be referring to each piece by its actual name for the rest of the video, and yeah, for all the lessons. So feel free to take some time to take some notes here. The most obvious one is the wing, and then you have what is called the fuselage, or the body of the aircraft. And then you have the two tail components. You have the vertical stabilizer on top, and then the horizontal stabilizer, which you can see off to the side. Lastly, you may have noticed, unlike traditional airplanes, we are not going to have engines on the side, but it has most of its components. See, it has the vertical and the horizontal, along with the wings itself and the fuselage. Now, we're going to go over some of these parts in a bit more detail and better understand what they actually do and why they're important. The first part of the glider we're going to be talking about is one that many of you are familiar with, and that is the wing. To best understand what the wing does, we have to first understand four forces. On a traditional airplane, four forces are acting upon it while airborne. The first one we're going to begin with is one that you guys are all familiar with, and that is weight. Weight is the force that's caused by gravity, and as you all know, it's what keeps us glued to the earth. In the same way, it's the force that is trying to bring our airplane back down to the ground. And so we can all blame gravity for why our gliders will not stay airborne forever. Next up is thrust. Thrust is the force that propels the airplane forward. And once again, on an airplane, that would be most commonly generated by the engines. However, our glider does not have engines, or any source of thrust for that matter, and which is why our glider's forward speed will never get faster once it leaves our hands. It's only going to be slowing down. And the only exception would be if a gust of wind or something else gave it a little push while airborne. So we've talked about why it falls down, how it goes forward, or the lack of why it doesn't get pushed forward. The next one is about up. The third force is lift. And this is where we talk about the wing itself. Lift is generated by the motion of the glider through the air, and it's the force that acts perpendicular or 90 degrees to how the airplane is flying, and it is a friend against gravity. This is where we talk about the wing. The wing is the greatest contributor of lift for our glider. The prime example of how this can be shown is by taking the wing off of our glider. So I have here a glider without the wing. Now try flying this. Well, before you fly it, think about what you think is going to happen. What happens when the greater contributor of the fight against gravity is gone? Yeah, that's right. It comes quickly down to Earth, or at least much quicker down to Earth than previously. Why don't you try it out? Feel free to pause the video now. Okay. So has it become pretty apparent why the wing is so important? And although I'm not going to go into it in the video, a great question to Google or search more information about is how lift is generated by the wing. And lastly, the final force acting on our airplane is drag. Now, drag is what is holding our airplane backwards from going forward. And the classic example of drag is when you're running really fast outside and you feel this air that's pushing against your face and body, and that's exactly what drag is. It's also why, even though our gliders will not be going forward faster, it is going to be slowing down as it is gliding through the air. Speaking of the wing, in the real world, you're going to see wings of all shapes and sizes. You're going to see wings swept forwards and backwards. Swept as in a wing that's swept forward is like the NASA Experimental 29 aircraft, or swept backwards, which is most traditional, like a Boeing 787. You're also going to see wings of varying different sizes, such as a triangle, like in the Concorde, rectangular, like a PA-38, elliptical, like the Supermarine Spitfire, and even trapezoidal, like an F-22 fighter jet. Each shape and placement and angle and position of each wing are designed to fit the purpose of each aircraft. So it's hard to say where is the best place to place a wing or what is the best wing. However, if you want to learn more about the science behind wing design, a really good place to start would be by asking yourself, why are gliders' wings angled upwards? So, if you haven't noticed, if you hold the wing right in front of you, you're going to see that there is a slight upward angle to our wing. And that makes our wings dihedral. So why is that? Why is our glider dihedral? And why most traditional commercial aircrafts are also dihedral? What happens if you flip them down and they become anhedral or angle downward? What's going to change? Feel free to look more into it yourself. And that is my challenge question to you. The next two parts are the vertical and horizontal stabilizers. Both parts are found in the tail of the glider, and to best explain what they do, I have to first explain three rotational modes of an aircraft. We know the typical ways of the movement of an airplane, which were partly covered when we talked about, when we talked about in the previous slides about the forces. So for example, an airplane can move up it can move down, it can move forward and backward, and it can even move side to side. However, in addition to these, an airplane can also spin. Okay, so I want you to hold the airplane up like this and do it with me. It can roll, it can yaw, and it can pitch. Do you see that? So let's do it one more time, okay? It can roll, it can yaw, and it can pitch. So if you think you understood those 3 rotational dimensions, again, roll, yaw, and pitch, you're gonna see that the vertical stabilizer, which is the top one here, the vertical stabilizer helps the airplane control its yaw. So if you think about the yaw motion, it's kind of like how a car would turn to the left or to the right. Maybe backwards in your video, but left and right, right? In an actual airplane, the vertical stabilizer uses movable surfaces. You can see the picture of it. Movable surfaces called rudders to turn yaw back and forth. So if we remove the vertical stabilizer, you'll notice that the glider actually has a much harder time flying straight forward. So in previously, when you had a completed glider, it generally flew pretty straight, unless your wings or stuff were like lopsided or not centered. But once you remove the vertical stabilizer, you're actually going to see that when you glide it, it's going to be much more sensitive to going to the left and going to the right. So try it. Feel free to pause the video now. Okay. Once you saw the value of the vertical stabilizer, in the same way, the horizontal stabilizers, the ones on the side, helps the glider to control a rotational direction. And the rotational direction it controls is pitch. Remember? Pitch. The horizontal stabilizer helps with pitch by creating lift, just like the wing. In an actual airplane, the horizontal stabilizer uses a movable surface called elevators to pitch the airplane back and forth and back and forth. We'll touch a bit more on pitch in the next video when we explain the center of mass versus the center of lift. But for now, try flying the glider without the horizontal stabilizer. It's much harder to spot the difference than when you remove the vertical stabilizer, but you're going to notice the flight isn't as controlled, as in the glide isn't as stable, and it's going to be much more prone to tipping up or tipping down, because now there is only one source of lift, and it's not well balanced. Now, just like the wing, there are many different types of tails in the real world. There are conventional tails, just like our gliders, as you can see in the A380. There are T-tails, V-tails, H-tails, and even some without tails. The B-2 bomber is actually one of the most amazing aircrafts ever flown. And if you want to learn more, try researching how an airplane without a tail can ever yaw back and forth to turn the aircraft. So that's going to be my challenge question to you. Research a bit more on the B-2 aircraft. You're going to find that it's fascinating. In particular, how does a B-2 aircraft turn? How does it ever yaw? Now, other than the body of the airplane and the pilot cockpit, that's it for lesson 1, guys. Hope you were able to learn something, or I became curious to find out more. In our next lesson, we'll be talking about the center of mass versus the center of lift. See you in the next video.